All right, now let's move on to an example. So sometimes people think, oh, mean, median, and mode, I got it. It's super easy. It's true. It's very easy to calculate. But then there are going to be problems that don't necessarily ask you just to straight up calculate the mean, median, and mode, but ask you to sort of think about it more flexibly. And here's an example of that. So there were 9 people in a room who made an average salary of $40,000 per year. When someone walks in who makes $84,000 per year, what happens to the mean? Now here, you don't know each individual salary of these 9 people. All you know is that their average is $40K, right? And then you know that somebody else will walk in who makes $84K, right? So can you calculate the new mean of the 10 people in this room? Yes, you can. Here's how. So the previous mean of this sample, I'll call it X bar, was 40K, right? So I'll just write 40 for now, and later we'll have to add in that K. So $40,000. Now, since there were 9 people in the room, right? So there were 9 people. What we don't know is this, right? So I going from 1 all the way to 9, all right? What we don't know is the sum, right? That sum up there. But we do know that the average ends up being 40 for these 9 people. Now remember, there's that little, just that algebraic transformation I could do. I can multiply both sides by n and get the value of this. I don't know each individual value, but I know what the value of it is all added up. So if I do 40 times 9, then I get the sum of for 9, right? So I get that sum automatically. Now, in order to get the sum, or to get the mean for everybody in the room, right? So this is going to be my X bar for the 9 people. What about my X bar for all 10 people, all 10 new people? What I need is the sum of all 9 of my people, right? Add in 84, and then divide that whole thing by 10. Because this is now the sum of all 10 people, right? So I have the sum of 9 plus my last guy. That's the sum of all 10 people, right? And so because we know this guy, right, it's 40 times 9. And then divide that all by 10. So I'm just going to use just a random little Excel sheet to help me do this calculation. All right. So you could do this on a calculator. You could do it in your head. So here's 40 times 9 plus 84, all divided by 10. Right? So I get 44.4. So my new mean is 44.4, right? So before our mean was 40K, now it's 44.4K, right? So that's our new mean. So this is what I mean by it's not just a straightforward calculation of the mean. They sort of want you to think about what the mean is made up of, right? It's sort of made up of 2 pieces, the sum of all the values, and it's divided by n, right? So it's those sort of 2 pieces, right? Can you sort of play with those 2 pieces? All right. So here is another example. The mean of x and y is 20. The mean of x, y, and z is 17.5. So what is the value of x, right? So the mean of x and y, so we'll say X bar for just 2 of these guys, right? Goes from I all the way up to 2, right? Fancy. that equals 20. All right? But the x bar of sub 3, so of all three of those values, is I goes from 1 all the way to 3, x sub I over 3, right? This is 17 and a half, all right? Now, in order to get this, it would be nice to know what the actual, we would need x plus y, right? X plus y plus z, right? Divided by 3 equals 17 and a half. We actually have x plus y, right? Because this is actually x plus y, right? And so that is simply, so x plus y equals 20 times 2. I'm just going to multiply 2 on each side. Get 40, right? So we already have x plus y. So I'll put in my 40 plus z over 3 equals 17 and a half, right? And so I'll just multiply both sides by 3 and then subtract 40, right? So all right, so I'll just do that here. 17.5 times 3, right? And then I'm going to subtract 40. So that's 12.5. So z comes out to 12.5, or 12 and a half. And that makes sense because here, when it was just x and y, the mean was higher. When you added z in, the mean became lower. So we know that, oh, z must have been something low to sort of drag down the mean. And it is indeed 12.5. All right. So next, it says the average number of calories in a BK burger off their 15-burger menu is 700 calories. The average number of calories of the 12 burgers on the McDonald's burger menu is 670. What is the average calorie count when combining across BK and McDonald's menus? So here what we could do is get the sum, right, of the BK calories and the sum of all the McDonald's calories, and then divide by the total number of burgers when we combine across their menus, right? And so for the BK burger menu, it's 15 burgers, and each are 700 calories. Well, they're an average of 700 calories. So 700 times 15 should give us sort of the summed up number of calories, right? And then let's add that to the sum of all the McDonald's calories. So 670 times 12. Right? And then to get the average, so we've added all the calories up. To get the average, we want to divide by the number of total burgers we're talking about now, which is 15 plus 12, right? And so that's going to be, remember, you could always do it in your head and on paper, on calculator, whatever you want. I'm just going to do it on Excel just to show you. So you need to make sure about your parentheses. So 700 times 15, although it knows order of operations. So plus 670 times 12, right? And that's all in the numerator, right? All divided by 27. 15 plus 12. All right, so that is 600, what was it? Whoops. Something and 2/3. I forgot. I can't keep this up at the same time as this. So 686 and 2/3. 686 and 2/3. So that's the average number of calories for when we average across all the burgers on both Burger King and McDonald's menus. All right, so here's example 4. It says, create an example set where n equals 5, where the median is greater than the mean. Modify that set so that the mean is then greater than the median. All right, so let's start off by just putting down 5 slots, right? And so basically, we're looking for the median here, right? So that whatever that is going to be the median, right? But we want the mean to fall somewhere down here, right? And in order to pull that mean downward, what we would do is simply create more numbers down here, right? So create these numbers to be sort of farther away from the median, right? So let's make them 0, 0, and we'll make this 5, right? To sort of make that distance farther. And then we'll make these 6 and 7, right? So the median is really easy. We already have it. It's 5. It's in the middle, right? But what is the mean? Well, let's add these up and divide by 5. So 5 plus 6, 11, 7 plus 7 is 18. So 18 divided by 5 is going to be 3 and 3/5, right? So 3 and 3/5 are 3.6. And that is going to fall below 5, right? So here we have the median being greater than the mean. So 5 is greater than 3.35. Now let's modify that set so that the mean is greater than the median now. So what I would do is I just think about the mean as being more influenced by the actual little numbers in here, right? So I could probably keep a lot of these the same. But all I'd want to do is sort of like really weight down one side. So now if I do that, let's see what happens. The median obviously doesn't change, right? But let's see what happens to the mean. Does the mean change? So 11 plus 20 is 31 divided by 5. So now that's going to be 6 and 1/5, or 6.2, right? And here we see, oh, now the mean is greater than the median. So all you have to do is sort of, wherever you want your mean to be, you want to sort of weight one side or the other, right? And here, this is sort of a skewed, this is sort of skewed, and this is sort of skewed, but they're skewed in sort of different ways.